Welcome back. This is an Aleks training video on deducing valence electron configuration from trends in successive ionization energies. Remember, an ionization energy is the amount of energy you have to put into a neutral atom in order to get it to turn into a cation or to rip off one of its electrons. So some electrons are cheap. Anything to the left of the periodic table are very cheap. It doesn't take a lot of energy in order to rip off an electron. Anything to the right of the periodic table, especially group 8, is going to be very, very hard to rip off. In fact, if you go from group 1, which is cheap, and then you're in group 8, and then you rip a second one off, it's really a lot of energy. And then if you rip a third one off, it's even more energy because I'm making it less stable. Remember, group 8 is very stable, and it doesn't want to go into group 7. It doesn't want to have less electrons. It wants to have 8 electrons. And so you are going to have energies that are different depending upon which direction you're going. So this is I like this question. It says the first ionization energies of a period 3 element have the following pattern. Okay, so let's see. We'll look at the periodic table in a second. The first one's cheap. The second one is cheap, not real expensive. The third one's very expensive, and then even more. Okay, so the first two, making a positive 1 is no problem. Making a positive 2 is real cheap. Making a positive 3 is very, very hard. Okay, and then even more. My guess is this is where this made it an octet, this made it a noble gas, and then this is ripping it from group 8 into group 7. That's my guess. All right, so let's find out what elements are in group 3. What elements are in group 3? Well, group 3, remember the first one was cheap, the second one was cheap, and then the third one was expensive. So let's look in group 3. We've got sodium. Okay, if the first one were cheap, that would put it to neon. The second one were cheap. No, it would not be cheap because it already has 8, so it can't be sodium. Let's look at magnesium. Would the first one be cheap? Yes, it would be. To rip off one of these electrons wouldn't be very much energy. To rip off the second one, now it's only got 1 in its outer shell. It's not very expensive to rip off. Okay, then it would go to neon. The third one to rip off would be very expensive. The fourth one, even more expensive, and the fifth one, even more expensive. My guess is that it's magnesium. So that's how you do it. You're simply looking for what makes the most sense. Magnesium. What makes the most sense in terms of the ionization energies. Thank you.